So this is topic 5, question number 3. Consider the differential equations dy dx equals 2x minus y. And they give us axes provided. Sketch a slope field for the given differential equation at the 6 points indicated. So not on the x-axis, but all the other 6 points. So let's see. We just got to go point by point and figure them out. So at 0, 2, y prime would be negative 2. So I'll aim to have a slope of down 2 over 1. So there's my first little slope piece. At 0, 1, y prime would be negative 1. So aim to go down 1 over 1. This is where you could use the like the straight edge of your ID on test day if you wanted to like make your slopes accurate. At 0, negative 1, the slope would be positive 1. And then at 1, 2, and you don't have to write all these out. Like if you can do them in your head or you notice a pattern, like you don't have to write them all out. But maybe it's helpful. That would be 2 minus 2 is 0. So that's a horizontal tangent line right there. Maybe a max, maybe a min, maybe neither. At 1, 1, y prime would be 2 minus 1 is 1. And at 1, negative 1, 2 minus negative 1 is 3. So it's pretty steep for that one. Okay. Slope fields are usually pretty easy to draw. I kind of don't like that one because usually we draw enough pieces that you can see a pattern. That one doesn't look very patterny, but we didn't draw very many pieces of it. So guess that's good enough for that one. Number 2, or part B, I should say, find dy dx, or find the second derivative in terms of x and y. Find the second derivative in terms of x and y. So first derivative dy dx equals 2x minus y. The second derivative, let's pick on some people. What's the derivative, Maggie, of 2x? 2. And Logan, what's the derivative of y?
Is it dy dx?
It is dy dx. So 2 minus dy dx is not really the answer.
It's not the answer.
Why is that not the answer? It's not wrong.
In terms of x and y.
Yeah, I want it in terms of x and y.
Equals
So
2 minus 2x minus y.
yeah, I'll put 2x minus y in for dy dx. Careful with that minus sign. Make sure it goes to everybody. You could leave it like that. I'm going to go ahead and distribute 2 minus 2x plus y.
Particular
I
solutions.
think this was a question on one of our tests.
I think so. Yeah.
This looks familiar.
Or maybe it's because you're a calculus teacher.
Find the second derivative in terms of x and y. Okay, we did that. But then determine the concavity. So yeah, that's second derivative of all solutions for the curves of the given differential equations in quadrant 2.
Quadrant.
So in quadrant 2, up there, so what do we know is going on?
1.
That's quadrant 1. Let's pick quadrant 2. What do we know about values in quadrant 2?
Y is positive, x is negative.
So let's see, y is positive, x is negative. Or you could just write out y is positive, x is negative. So the second derivative then, 2 minus 2 times x, which is negative, might have been better to just write it out, plus y, which is positive, so 2 minus 2 times negative, that'll be plus, that'll be plus. This will definitely be positive. Right?
Yes.
Because I got minus a negative and then plus a positive.
Oh, okay.
So my second derivative will be positive, although I still haven't answered the question. Determine the concavity. Okay, so concave up. So y is concave up
You have to give a reason. Is that a reason?
in Q2 because second derivative is positive. I might even say always positive.
I'm going to say just positive because I don't want
Or maybe positive in quadrant 2 would be always positive in quadrant 2 if we really want to get specific. But it is worth your time to make sure you answer the question correctly, accurately. Again,
Next
don't
is,
write a paragraph, but be clear.
to. Next one is
Right? Let y of x be the particular solution with an initial condition of f of 2 equals 3. 2 equals 3. Does f have a relative minimum, relative maximum, or neither at x equals 2? Well, y prime at 2, 3 is 2 times 2 minus 3. Initial condition of f of 2 equals 3. I thought it would be a relative min or a relative max. Instead it's just 1.
so neither.
So neither.
No horizontal tangent line.
That would work. It's neither max nor min because y prime doesn't equal 0.
No horizontal.
It's not a horizontal tangent line. Either one of those. They mean the same thing. So that seems strange. I was expecting to get a max or a min and then have to use the second derivative to tell whether it was a max or a min. So I'm still doubting myself here. X is 2, y is 3. 4 minus 3 is 1. Part D. Find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation.
Are they just asking us for the tan line, weight and slope?
No, they're saying y equals mx plus b is a solution to that.
Do we have to take in
So
derivative?
let's see, dy dx, y prime. I can't take the antiderivative because I can't separate those variables. So y prime is, what's the derivative of mx plus b?
X.
Not x,
M.
m.
Yeah.
So that means, see if this will work, m equals 2x minus y,
2 minus 2x minus y.
which is mx plus b. So I'm starting with this.
Oh.
I'm substituting in dy dx and I'm substituting in y.
Okay.
And I need this thing to be equal to each other. So let's see. M equals 2x minus mx minus b.
There we go. I think.
and it said I need to find the values of M and B.
Could we use 2, 3?
I don't know that we know that 2, 3 is goes with this one.
Well, it says y is. Oh no, it wouldn't because. It's
Let's see how to get there from here.
If you just plug in the M instead of the y goes next, what's going to be the y up top?
Say that again.
Just plug in the M
For
top instead of plugging the y.
I plugged in M for dy dx, and then for y I plugged in. But y doesn't equal M. Y equals mx.
Are you supposed to try and put it in the y equals mx plus b form? So that would,
Oh, you want to?
it would be 2, and then your b would be minus n.
You're right. I'm still looking right here because I'm going to get it from here. Like,
to find out what b is and then.
just trying to think how to get this. I think I'll move the M over, and then so x times 2 minus M minus b minus M. So if I want all that to go away, then I need the x coefficient to be 0. So M is going to equal 2.
Okay.
And then if M equals 2,
B has to be 2 as well.
B has to be, wait,
Negative
2 or negative 2, I think. 2 minus 2, so that goes away. Minus B minus 2.
It has to be negative 2.
So B would need to be negative 2. That's why it's part D.
Trying to screw us over.
Maybe you could have got a point in there by finding y prime and getting to this spot. Maybe that would be worth a point.
Heck if we know.
I don't know. I'd have to look and see. All right, that one only took 12 minutes. And we
Even then
paused
got
and
stuck a couple times.
got stuck. We took our time. So again, it's not usually time that's the issue on the AP test, unless you get stuck and you don't move on. You just get stuck spinning your wheels and not going anywhere. Well, then yes, time would be a problem. But if you know what you're doing, even if you pause and restart, and you'll still be okay time-wise.